Hey everybody, in this video we're going to talk about temperature scales, and thermometers. Where we'll start is defining what temperature is. If we put our thermometer into some water, those molecules are moving around, and temperature is a measure of how fast those molecules are moving. The faster the molecules move, the higher the temperature. And so you can imagine that there's no real limit to how fast molecules can move. Temperatures can reach millions and even billions of degrees because the faster they move, the higher the temperature. But let's take it the other way and understand that molecules can slow down. They slow down. So we have our little water molecules here. Eventually they slow down. The temperature goes down and down and down and down. When temperature goes down and down and down enough, they just stop moving. And that point at which molecules stop moving is called absolute zero. Okay, that's absolute zero. A little more on that in a minute. Let's talk a little bit about temperature scales, thermometers. Okay, and so let's talk about the thermometer that you're probably most familiar with, and that's the Fahrenheit thermometer. So I'm going to put the Fahrenheit thermometer over here. And it turns out that the guy that developed the Fahrenheit thermometer was doing research and science on salt solutions, and he found that, some sort of salt solution he was working at melted at 0 degrees Fahrenheit. But when he used that solution, he also realized that ice water was at the temperature of 32 degrees Fahrenheit. Okay, so I'm going to put that on this thermometer here. Okay. Another guy came along, and his name was Celsius. And he had the same glass tube, but he had one that didn't have any markings on it. So he wanted to make his own markings. So it was pretty straightforward. He just took it. He was like, you know what? The point at which ice melts or freezes, I'm going to call 0 degrees Celsius. Okay? So this is the Fahrenheit scale, and this is the Celsius scale, and they're based on properties of water. Okay, this is the freezing point of water. And then they boiled water. Fahrenheit, when he boiled water, he realized that water boils at 212 based on his scale. And so if you do the math, there's 180 units here in between 32 and 212. Celsius wanted to make his scale a little easier, so he went from 0, and he said that the water boils at 100. So he has 100 units in here. The Fahrenheit scale has 180 units between the freezing point and the boiling point of water. And the Celsius scale has just 100. Kelvin came along. There was a guy named Kelvin. Okay, so I'm going to write his name on this thermometer. And he said everybody has it wrong. He said that what we need to do is we need to develop a scale. Instead of having 0 being the freezing point of water, we need to have 0 be the point at which everything stops moving. He calls that absolute 0. So he took and he said, well, let's take the lowest possible point and let's call that 0. Okay? And then he realized that when he did this, that the freezing point of water was at 273 Kelvin. And then he realized that when he did this, he developed the scale to be based on the Celsius scale, and that he realized that the boiling point of water on his scale was 373 degrees. So this here is still just 100 units between the freezing point and the boiling point. Okay? And keep in mind that Kelvin is our base unit for temperature. So in science, we want temperatures in Kelvin. The way to convert between Celsius and Kelvin is pretty straightforward. You take the temperature in Kelvin, and that's going to equal the temperature in Celsius plus 273. Here, On the Celsius scale, absolute zero is at negative 273. One of the beauties of the Kelvin scale is that there are no negatives. Okay, there are no negative values. Now, the problem with the Fahrenheit scale is that you have 180 units between the freezing point and the boiling point. And here you have 100, so you have to do some interesting math. If you're converting from Fahrenheit to Celsius, you need a little more complicated formula, and that's going to be that the temperature in Fahrenheit equals the temperature in Celsius times 1.8. And that 1.8 comes in the fact that there's 180 units here and only 100 here. And then you add 32 because this is 0 and this is 32. And so when you do this math, you realize that the absolute zero in the Fahrenheit scale is about negative 459 degrees Fahrenheit. Okay, so what I'm going to want you to know is the boiling point and freezing point of water in all these scales. Okay, so for Fahrenheit, you need to know 212 and 32 is the freezing point. For Celsius, you need to know 100 is the boiling point and 0 is the freezing point. And in Kelvin, you need to know 273 is the freezing point and the boiling point is 373. So now let's do a couple of just really quick conversion problems. So let's say we have a temperature of 52. We wake up in the morning and it's 52 degrees Fahrenheit out. Okay. Well, we want to know what that is in Celsius. So we're going to use our conversion, which is degrees Fahrenheit equals degrees Celsius times 1.8 plus 32. Okay, so we're going to plug in 52 equals degrees Celsius times 1.8 plus 32. So now in order to solve, we have to subtract 32 from each side, minus 32. And so that's 20 equals degrees Celsius times 1.8. And then so we divide both sides by 1.8. Divide by 1.8. I don't know why that's sideways. Divide by 1.8. And we do our math, and we get that the temperature in Celsius is 11 degrees Celsius. So now what if we're trying to go to Kelvin? So a scientist is in the lab and he measures the temperature to be 71.9 degrees Fahrenheit, and we're going to go to Kelvin. Now we don't have a direct conversion from Fahrenheit to Kelvin. So we have to go from Fahrenheit to Celsius up to Kelvin. Okay, we have our Fahrenheit conversion, we have our Kelvin conversion. Okay, and Celsius is the middleman here. So we're going to go, okay, that our temperature in Fahrenheit equals the temperature in Celsius times 1.8 plus 32. Okay, so we get 71.9 equals the temperature in Celsius times 1.8 plus 32. So we're going to subtract 32 on each side. Remember, orders of operations, you got to subtract. You can't do the parentheses first, so we subtract 32. So we get 39.9 equals temperature in Celsius times 1.8. So we divide both sides by 1.8, and we get 22.16 repeating as our temperature in Celsius. But that's not what we want. We want it in Kelvin. So now we're going to take this and we're going to convert it to Kelvin. And so Kelvin equals the temperature in Celsius plus 273. So then we just plug this in. Equals 22.16 plus 273. That's repeating. When we do that, we get Kelvin. The temperature in Kelvin is equal to 295. Okay, The math answer you get is 295.16 repeating, but significant figures. This has 3 here, so when we come down here, that's 3. And finally, we write Kelvin. Kelvin does not have a degree sign, so don't put the degrees there. There's a couple of conversion problems. Okay, so I hope this helps, and have a great day.